Moni, thank you very much for your friendly presentation. I'm going through some rules related to design compressive stress of concrete and partial safety factors very quickly. First, green concretes, Hans has explained perfectly that there are some concretes where cement is replaced total or partially by another binder, like flashes and so on, with the objective to reduce carbon footprint, but this needs, implies a slower strength development, and then the reference age to test the control specimens has been between 4 weeks and 13 weeks, that's 91 days. So I think that EC2 does not regulate right now green concrete, but at least left the door opened to its use. Second flash is related to design compressive strength of concrete, the unification, what has been done by Professor Mutoni, very interesting. We have, you see here, really several compressive strengths of concrete. We have the compressive strength of the control specimens, FC seal. On the other hand, the actual in situ compressive in undisturbed structure, that's the structure without reinforcement, without longitudinal and traveler reinforcement, and one coefficient HyA to convert one to the other. The differences between both are the casting conditions, the curing conditions, the behavior of fresh concrete different in the control specimen than in the actual concrete. And then we have the real structure with all the reinforcement and another, in this case, new coefficient to transform this strength into the real structure, the eta CC, which takes into account mainly the influence of the brittleness of high strength concrete. Some effects not considered, like the strain simplifications, plain section remain plain, for example, Navier hypothesis, local effects, the influence of the reinforcement generates stress concentrations, restraint effect, and the deviation of the stress field generating tension stresses due to the reinforcement and the bodies. So with these different compressive strengths, we have the design compressive strength of concrete by this product, eta CC, this brittleness coefficient, KTC, which takes into account the high sustained load and the load time, and FCK, and GAM capital C, which take into account several questions like via gamma small cap C, the material and geometrical uncertainties, gamma R, the model, the resistance model uncertainties, and eta IS, what I've seen, the conversion factor from control specimen to undisturbed structure. All these coefficients, in particular eta CC, has been calibrated by columns in laboratory. This new design compressive strength, in my opinion, has some advantages. First, the reduction coefficient nu, which is applied in several ways of work, in bending, in shear, in punching, and so on, is independent now. It's the same. It's independent of the characteristic resistance. As you can see here, the provision for shear with constant values, at least not dependent of the strength of the concrete. You see shear web flanks, torsion, strat models. And on the other hand, stress distribution has been simplified, as Hans has said. The parabola rectangle, now the deformations are the same independently of the class of the concrete, 0.2%, 0.35. And on the other hand, also the block, the rectangular block, the dip of the rectangular block is constant, independent of the strength of the concrete. This modification, even in parabola rectangle, has improved the results in relation with database. The third question is related mainly to the Annex A, is the possibility to adjust partial factors for materials. I've highlighted 4 points. First, we know, finally, we know now how are the hypotheses which underlies the standard values for partial factors. We have a procedure to modify these partial factors if our variables of the materials are different than that supposed. And we have, besides a new partial factor for concrete, gamma V, and we may use a design value of the effective depth instead of the nominal value as usually. So I'm going quickly to see these 4 points. The hypothesis for this coefficient, for example, typical 1.15 or 1.15 for concrete and for steel, is based on tolerance class 1, execution class 2 of code of execution of concrete structures, and some values of variability of the components of these strengths by means of coefficient of variation and bias factor. So, for example, for concrete, we have for compressive strength a variation coefficient of 0.1 and a bias factor as with this exponential relation. If we have that are the data to calculate the gamma C coefficient. If we have another coefficient of variation in our problem, we may change as we are going to see after. But we know what are the bases of our coefficients. So if we have different values, the resistance RC of any idea of compressed concrete is done by this product, the compressive strength of control specimen, the conversion coefficient eta IS, the idea of concrete, and the model uncertainty. All these variables, even the resistance RC, are treated as log normal distribution as they have not negative values. So the variation coefficient and the bias coefficient in function of these variables are done by this expression. And finally, the partial safety factor is related with alpha R with the sensitivity factor of resistance. That means this is the part of the reliability that is supported by the material. There is another part supported by actions. Normally it's 0.8. The reliability index normally 3.8. And after the coefficient of variation and the bias factor of the resistance. So with all these elements, if we change someone, because we have data of test or something like that, we may recalculate this coefficient. In fact, the Annex A has several typical cases for modifying this coefficient. For example, when tolerance class 2 is used instead of class 1, when we have data, measured data of geometrical dimensions, of strengths of reinforcement of concrete, and so on. In these cases, the Annex A gives the coefficient. For example, in the first example, the new coefficient would be 1.48 and 1.08. There is a table with all these cases and the resulting values. New partial factor for gamma V. It has seen that model uncertainties become dominant, and then the influence of the strength is reduced because the exponent is 1/3. So it has been generated a new value for gamma C to be applied in here, and it's called gamma V, which fit very good with the databases. This value is less than 0.15. For example, typical case is 1.40, and then the fitting with the formulation, as I said, is better than the other one. And finally, the use of effective value of design value of effective depth. It has seen that thin members geometrically static governs the behavior. So if you see the blue line represents the reliability index for gamma of 1.40, and using the nominal